All right, so 2019 now. Oh no, we're doing specimen paper 2018 now. So you tackle it. This one isn't a proof per se, but it's a calculation question. And I'll show you some nice little tips to make life a little easy in questions like this. Now, everybody likes working in degrees because it's easy for me to split up 45 degrees. 45 degrees is 20 plus 25. 100 degrees is 60 plus 40. 90 degrees is 30 plus 60, 45 plus 45, and so on. But when I have to split up an angle expressed in radian format, it's a little difficult because we're so unfamiliar with the looking at radians. So for example, pi on 12. How am I splitting that up into two separate angles? This is a compound angle formula. It's a compound angle question. And we need to know, again, angles and their exact values. Sine, cosine, and tan of 30, 45, and 60 degrees. So let me cheat a little bit. But the cheating, CXC not going to see this. So raise your hand. Miss, I can get a piece of paper, please. Ask for a scrap piece of paper. Examiners, they can't deny it. They have to give you an extra piece of paper if you need more paper. And do your working on your own. Don't let CXC see this, please. Please, please. I want to know what pi on 12 is in degrees. This is pi on 12 multiplied by 180 over pi. Pi cancel with the pi. Jump on your calculator. 180 divided by 12 is 15 degrees. So homeboy is 15 degrees. How am I splitting up 15 degrees? 15 degrees could be 60 minus 45, or anything else? 90 minus 75. Right, so 60 minus 45 looking like the way to go. But I have to use the information the question gave me. The question told me that tan of pi on 4 and pi on 6. Luckily, pi on 4 is 45 degrees. This is pi on 4. And actually pi on 6 is 30 degrees. So it could be 45 minus 30 degrees. That's the next way to get the 15 degree angle. Where this going to be my pi on 4 and this going to be my pi on 6. So this here is the transition for my compound angle formula. So I say now, pi on 12 is equal to tan of pi on 4 minus pi on 6. Then I'll recall my compound angle formula. Tan of A minus B. Remember, the minus sign goes on top. Tan A minus tan B, and the opposite operation goes below. 1 plus tan A tan B. So tan of pi on 4 minus pi on 6 is tan pi on 4 minus tan pi on 6 all over 1 plus tan pi on 4 multiplied by tan of pi on 6. Tan of pi on 4 in the information is 1. Root 3 over 3. 1 minus root 3 over 3. Use your lines. All over 1 plus 1 multiplied by root 3 over 3. This is, I using my shortcut. This is 1 over 1. This is 1 over 1. Root 3 minus root 3 all over 3 divided by 3 plus root 3 all over 3, 3 minus root 3 over 3 multiplied by 3 over 3 plus root 3. You cancel with you. 3 minus root 3 over 3 plus root 3. Good Lord. Alright, cool. Sorry about that. Now, we can check we work for questions like this. Remember, tan of pi on 12 has a particular value. Tan, let me change my calculator in radians, 0, 1. Tan of pi over 12 is this. So I'll store this in A. And I think on one of the videos on the channel, I showed how to use the storage functions and calculators. So I have tan of 15 degrees. 3 minus root 3 divided by 3 plus root 3.2679. I'll store that in B. If tan of 15 and this is the exact same thing, then A minus B should be 0. A minus B is equal to 0. Now, the question didn't really say, I don't think it did say to give it in any particular form. So if you wanted to leave it here, you could have, but I don't know if CSEC will probably take out a mark from it because it didn't simplify it. Let me check and see here. In simplest third form. So you'll want it in the form I gave it here. Now, if you want to rationalize this homeboy, you could go ahead and rationalize it and show off, but it doesn't make a big difference. So now we on 2019, then 2021. Right, so we'll do 2019, then 2021 on this side. 2019 is a proof, 2021 is a calculation. We go orange that one up, and we go blue that one up. All right, so this is a very simple proof. This is a proof that we did in the last video. 1 over cos squared theta is sec squared theta. This is one of the big boy proofs. So I'll taking the left hand side, I have tan squared theta plus 1. Then I'll recall the base identity, sine theta over cosine theta, which implies tan squared theta is sine squared theta over cosine squared theta. So I have sine squared theta over cosine squared theta plus 1. I'll do my so, right? And you'll hear me referring to that often. So and so whenever I add into fractions. So this is equal to sine squared theta plus cos squared theta over cos squared theta. Recall that sine squared theta plus cos squared theta is equal to 1. So the identity turns out to 1 over cos squared theta, which is the right hand side, QED. Now please do not be tempted to start with sine squared theta plus cos squared theta and work your way to this. The question asks us to prove that the right is equal to the left. So don't pull out a new right hand side and make it equal to 1 over cos squared theta. Please use what they give you. So the last one to end of the video, cosine m is that, and m is acute. If m is acute, then solutions are in the first quadrant, and all trigonometric ratios are positive in the first quadrant. I think it's tan 2m. Yes, it's tan 2m. So our next compound angle formula in terms of tan. So what I realized in all the questions, the compound angle for formula for tan, it came quite a bit. So take note. I'll draw my right angle triangle because I know, oh Lord, okay, better than that, man. Good. I will recall cosine of any angle, we'll call m, is adjacent over hypotenuse, which is 24 over 25. This could imply that the adjacent is 24. If this is the angle m, my opposite is here, my adjacent is here. So this is 24, my hypotenuse is 25. I'll use Pythagoras theorem. The hypotenuse squared is the opposite squared plus the adjacent squared. 25 squared is equal to opposite squared plus 24 squared. You can rearrange one time and calculate for the opposite. 25 squared take away 24 squared is 49. So the opposite could be the square root of 49, which is 7. So homeboy is 7. And we what tan 2m. So life easy, man. Tan 2m is equal to the compound angle formula for tan 2 theta is 2 tan theta, or in this case is m, over 1 minus tan squared m. I can figure out what tan of m is. Tan m is equal to opposite over adjacent, 7 over 24. So therefore, tan of 2m is 2 multiplied by 7 over 24 all over 1 minus tan m squared. Tan m all squared is tan squared m. Simplify the top. Top becomes 7 on 12 over 1 minus 7 over 24 squared. And we can work this whole thing out on a calculator. 1 minus 7 over 24 squared is that. And 7 over 12 divided by this. But the answer is 336 over 527. Now, it's looking like a kind of weird answer. I believe this is accurate. Let me just check it with my solutions here. All right, so in the meantime, if anyone has any requests that they would like to voice, please voice them in the comment section below. Whatever I want to see, let me know. I will try to have some crash courses for the AdMats. If you are interested in the crash courses, feel free to WhatsApp me. My WhatsApp is 7934754. WhatsApp me telling me, sir, I want to see so by so. I want to see so by so. And I'll try to facilitate and make something happen. All right, so yes, that is the answer. 336 over 527. So again, 7934754. If you all need any help with anything at all, and you all want the kind of individual attention, I will try to facilitate you guys. If more than one person wants the same thing, it's not going to be individual. I'll end up just forming a little small class for you and teach all you. If all you want to know Riemann and factor theorem beginning to end, I go do that in one class. All right, so message me, we go look to organize, and leave a like, share the video for those who might need it, and I'll see you guys in the next one.